The homeowner's plan presents two primary issues. Firstly, the proposed use of 10/4 SO code for a permanent installation violates electrical code. SO code, or service code, is designed and rated for flexible, temporary applications such as powering portable tools or equipment. It is not intended as a substitute for permanent wiring methods like ROMICs or conduit-based systems. The National Electrical Code, or NEC, specifically outlines acceptable wiring methods for different applications, and SO code does not meet the requirements for permanent installations due to its construction and insulation properties. Using SO code in this manner could lead to premature wear and tear on the cord, increasing the risk of electrical shock or fire. The insulation may degrade over time when exposed to environmental factors or physical stress, compromising its ability to contain the electrical current safely. Secondly, the plan to connect the generator to the transfer switch without a dedicated circuit is also a violation of the NEC. A dedicated circuit is one that serves only a single purpose and does not share its capacity with other electrical loads. This requirement ensures that the generator has a reliable and uninterrupted path to supply power to the transfer switch without being affected by other appliances or devices connected to the same circuit. By attempting to connect the generator to the same circuit used by the transfer switch, the homeowner is creating a potential overload situation which could trip breakers or damage the generator or other electrical equipment. Furthermore, it complicates the process of isolating the generator power from the utility power, which is a critical safety measure when using a transfer switch. The proper solution is to install a permanent feeder from the generator to the transfer switch. This feeder should consist of appropriately sized conductors installed in a raceway, such as conduit, or using a cable assembly specifically rated for permanent installations. The size of the conductors should be determined based on the generator's output capacity and the anticipated load requirements, consulting NEC Table 310.15 for ampacity ratings. The feeder should originate from a dedicated circuit breaker or fuse disconnect switch that is sized to protect the conductors and the generator from overcurrent conditions. The installation must adhere to all applicable sections of the NEC, including requirements for grounding, bonding, and overcurrent protection. The conduit or cable assembly should be properly secured and supported along its route, and all connections should be made in approved electrical boxes or enclosures. A licensed electrician should perform this work to ensure that it meets all code requirements and safety standards. This approach ensures a safe and reliable connection between the generator and the transfer switch, providing a dedicated path for the generator's power and minimizing the risk of electrical hazards. It also maintains the integrity of the electrical system and complies with all applicable regulations, ensuring long-term safety and performance. When selecting the appropriate size conductors for the permanent feeder, several factors must be considered. Firstly, the ampacity of the conductors must be sufficient to carry the full load current of the generator. This information can be found on the generator's nameplate, which specifies the maximum current output at its rated voltage. Secondly, the voltage drop in the conductors must be kept within acceptable limits to ensure that the voltage at the transfer switch remains within the tolerance range of the connected loads. The NEC recommends limiting voltage drop to no more than 3% for feeders and 5% for branch circuits. Thirdly, the conductors must be protected against overcurrent by a circuit breaker or fuse disconnect switch that is sized according to the conductor's ampacity rating. The NEC provides tables that specify the maximum allowable overcurrent protection for different conductor sizes. In addition to conductor sizing, the type of raceway or cable assembly used for the permanent feeder must also be selected carefully. Conduit offers excellent physical protection for the conductors and is suitable for both indoor and outdoor applications. Different types of conduit are available, such as rigid metal conduit, intermediate metal conduit, electrical metallic tubing, and flexible metal conduit, each with its own advantages and disadvantages. Cable assemblies, such as Type MC cable or Type AC cable, provide a convenient alternative to conduit and are suitable for many indoor applications. These cables consist of insulated conductors enclosed in a metallic sheath, which provides mechanical protection and serves as a grounding conductor. All electrical connections must be made in approved electrical boxes or enclosures to protect them from physical damage and environmental factors. These boxes should be made of metal or non-metallic materials and should be properly grounded to provide a safe path for fault current. The connections should be made using appropriate wire connectors or terminals that are rated for the size and type of conductors being used. The entire installation must be inspected and tested by a qualified electrician to ensure that it meets all code requirements and safety standards. This inspection should include verifying the proper grounding and bonding of the system, testing the insulation resistance of the conductors, and measuring the voltage and current at various points in the circuit. Any deficiencies or discrepancies must be corrected before the system is put into service. By following these guidelines, the homeowner can ensure that the generator is connected to the transfer switch safely and reliably, providing a source of backup power during outages. A permanent feeder installation not only meets code requirements but also provides a more robust and durable solution compared to using so-called or other temporary wiring methods. Furthermore, it simplifies the process of connecting and disconnecting the generator, making it easier to use during emergencies. The installation of a permanent feeder from the generator to the transfer switch involves several key steps. Firstly, determining the appropriate location for the generator and the transfer switch. The generator should be placed in a well-ventilated area, away from flammable materials and sources of ignition. The transfer switch should be installed near the main electrical panel, where it can easily disconnect the utility power and connect the generator power. Secondly, running the conduit or cable assembly from the generator location to the transfer switch location. The conduit or cable should be routed in a manner that minimizes physical damage and protects it from environmental factors. It should be properly supported and secured along its route, using appropriate clamps or straps. Thirdly, installing the necessary electrical boxes and enclosures along the conduit or cable run. These boxes should be located at all connection points, such as where the feeder connects to the generator and the transfer switch. Fourthly, pulling the conductors through the conduit or cable assembly. The conductors should be sized according to the generator's output capacity and the anticipated load requirements. They should be carefully pulled through the conduit or cable to avoid damage to the insulation. Fifthly, making the electrical connections at the generator, the transfer switch, and all intermediate boxes. The connections should be made using appropriate wire connectors or terminals that are rated for the size and type of conductors being used. Sixthly, grounding and bonding the system. The grounding and bonding connections should be made according to the NEC requirements to provide a safe path for fault current. Seventhly, testing the system. The system should be tested to ensure that it is functioning properly and that all connections are secure. The testing should include verifying the voltage and current at various points in the circuit, as well as testing the operation of the transfer switch. If any problems are found during testing, they should be corrected before the system is put into service. The homeowner should also be instructed on the proper operation of the generator and the transfer switch. They should be shown how to start and stop the generator, how to switch between utility power and generator power, and how to troubleshoot common problems. They should also be warned about the dangers of carbon monoxide poisoning and the importance of using the generator in a well-ventilated area. By following these steps, the homeowner can ensure that the generator is connected to the transfer switch safely and reliably, providing a source of backup power during outages. The permanent feeder installation not only meets code requirements but also provides a more robust and durable solution compared to using so-called or other temporary wiring methods. Furthermore, it simplifies the process of connecting and disconnecting the generator, making it easier to use during emergencies. The installation of a permanent feeder from a generator to a transfer switch is a critical electrical task that demands careful attention to detail and adherence to safety standards. It's not just about providing backup power, it's about ensuring the safety of the electrical system and the people who rely on it. Firstly, understanding the generator specifications is paramount. The generator's nameplate provides vital information, including its rated voltage, maximum current output, and power rating. This data is crucial for determining the appropriate size and type of conductors needed for the feeder. Secondly, conductor sizing is a critical aspect of the installation. The conductors must be able to safely carry the generator's full load current without overheating or causing excessive voltage drop. The NEC provides tables that specify the ampacity of different conductor sizes, taking into account factors such as insulation type, ambient temperature, and the number of conductors in a raceway. Thirdly, overcurrent protection is essential to protect the conductors and the generator from damage caused by overloads or short circuits. A circuit breaker or fuse disconnect switch should be installed at the generator end of the feeder, sized according to the conductor's ampacity rating. The NEC provides guidelines for selecting the appropriate overcurrent protection device for different conductor sizes and applications. Fourthly, the choice of raceway or cable assembly is another important consideration. Conduit provides excellent physical protection for the conductors and is suitable for both indoor and outdoor applications. Different types of conduit are available, each with its own advantages and disadvantages. Cable assemblies, such as Type MC cable or Type AC cable, offer a convenient alternative to conduit for many indoor applications. Fifthly, grounding and bonding are crucial for safety. The generator, the transfer switch, and all metallic enclosures must be properly grounded to provide a low impedance path for fault current. Bonding ensures that all metallic parts of the electrical system are electrically connected, minimizing the risk of electrical shock. Sixthly, proper connections are essential for a reliable and safe installation. All electrical connections must be made in approved electrical boxes or enclosures, using appropriate wire connectors or terminals. The connections should be tight and secure to prevent overheating and arcing. Seventhly, testing and inspection are the final steps in the installation process. A qualified electrician should inspect the installation to ensure that it meets all code requirements and safety standards. The system should be tested to verify its proper operation, including voltage, current, and grounding. The homeowner should also be instructed on the proper operation of the generator and the transfer switch, including safety precautions. By following these guidelines, the installation of a permanent feeder from a generator to a transfer switch can be performed safely and reliably. This provides a valuable source of backup power during outages, while also ensuring the safety of the electrical system and the people who rely on it. In addition to the technical aspects of the installation, there are also some important safety considerations to keep in mind. Firstly, always disconnect the power before working on any electrical equipment. This includes disconnecting the utility power at the main electrical panel and disconnecting the generator at its disconnect switch. Secondly, use insulated tools when working on electrical equipment. Insulated tools can help to protect you from electric shock. Thirdly, wear appropriate personal protective equipment, or PPE, such as safety glasses, gloves, and a hard hat. PPE can help to protect you from injuries caused by electrical hazard. Fourthly, work in a well-ventilated area. Generators produce carbon monoxide, a colorless and odorless gas that can be deadly. Fifthly, follow all applicable codes and regulations. The NEC provides detailed guidelines for electrical installations, and it is important to follow these guidelines to ensure safe and reliable installation. Sixthly, if you are not qualified to perform electrical work, hire a licensed electrician. Electrical work can be dangerous, and it is best left to the professionals.